Hello, ladies and gentlemen, Mr. Gazda here. This is Notes 120. It's on weathering and groundwater. Let's get started. So, first off, if you have this, pause the video and copy this down. Okay, I'm back. This is about weathering. Commonly, weathering and erosion get confused. Weathering is a natural breakdown of rock. Think of a big rock cliff. It's getting broken down into smaller rocks. It could be boulders, and then further down to cobbles, bowling ball sized rocks, to smaller, to pebbles, to sand. It's breakdown like that. Natural. Okay. The weathering and erosion often get set together, and they get confused. But so weathering is the breakdown of rock into smaller pieces. Erosion is then transporting that weathered rock, be it a rock the size of my fist, or a boulder, or sand, something moving it. And some things, agents of erosion, for instance, would be water in streams and glaciers, wind for smaller particles. Those are some examples. So you want to make sure we make a differentiation between those two. And sediments are broken down pieces of rock, and the list of sediment sizes, we've seen this already, from smallest to largest: clay, silt, sand, pebbles, cobbles, and boulders. New York State reference table, this is really where it kind of shows them. It shows their ranges here. Clay's the smallest, silt, sand. You gotta know sand is fine sand and larger sand. Pebbles up to about 6.4 centimeters, cobbles and boulders. That's where you can find it for those people who have this reference table. Okay, two types of weathering. As a matter of fact, why don't you pause it and copy this down, please. Okay, two types of main categories of weathering: physical weathering and chemical weathering. Physical weathering is what we're going to focus on first, and it's also called mechanical weathering, and that is any sort of weathering that just changes the size and shape of the rock or sediment. So it's going to stay the same mineral, stay the same rock. There's no chemical changes into something else. So that's one of the key things: chemical versus physical change. The breakdown of rock that only involves a change in size and shape, not the composition. The first one we're going to focus on here is frost action or frost wedging. And it happens when water gets into a rock, or think of it into a crack of a rock, when it's liquid water, and then it gets cold below freezing, 32 degrees Fahrenheit. And then when water is unique in that when it freezes, it will expand. And expands about 9%. And the force of that expansion can be tremendous, and it can actually crack rocks apart, and it does crack rocks apart. So 9% is in here. So this is just a simple diagram I have of like a sort of a rocky cliff, and the water gets in these cracks, and usually repeated cycles of freezing and thawing. Once is not enough. It's going to make a really small crack a little bit bigger, and then the water gets down further, and then it will freeze again, and it makes that crack bigger and bigger, and it's these repeated cycles of it that will cause, like this boulder here, to then fall off. Let's look at some examples of this. This is a picture that I took. This is in Western Massachusetts on a hike that I was on. So this gigantic boulder here, and you see how like almost perfectly split it is. It looks like someone did this on purpose. That's a baseball hat here for scale. So this was a boulder that was about this big, and that must have been some sort of crack in there. Natural small crack that over many years sitting there, many repeat freeze-thaw cycles caused that boulder to crack. So you really can see that there. I like to show this example. This is the Old Man on the Mountain. This is in, it's in New Hampshire. Okay, and if you can see, this is a famous landmark in New Hampshire, Old Man on the Mountain. Chin, mouth, nose, eyes, sort of weird protruding forehead. And this is the before picture. I said it is in New Hampshire. I really should say it was in New Hampshire. And this, even, it is such a big deal in New Hampshire. It is on the back of their quarter, Old Man of the Mountain. They show it there. They were very proud of it. Though, unfortunately, a few years ago, I remember the news story was that there was a rock slide here, and then this happened. And people in New Hampshire were bummed. They were not happy about this at all. Man, they were bumming because it was such a key part to their, such a central part of their heritage of their state. And so this happened, and that is mainly because you can get a sense here. It is due to weathering, and this is bound to happen over enough time. And the freeze-thaw cycle, especially in a place like New Hampshire that has a really cold winters, and all the cracks, natural cracks in that rock, led to this happening. And this has been, probably an ongoing process over many years. And this is collapsed in May of 2003. So I have the date in here, if you can see that. And it superimposes the previous image on there. So all this rock slid. And so that's just another real-life example. This here you can kind of see. And I like the fact that this photograph here has, this is in Alaska, I believe. I don't have it written down. And I see all the snow in the background and get a sense of the cold climate. And you see how this boulder is broken here. That is a good, really visual showing the freeze-thaw. I have this in here because it is showing the natural cracks that occur in any sort of bedrock. As we've learned, most of these rocks form very deep underground, and they have a lot of rock and weight on top of it. So when it gets towards the surface, all that other rock has been eroded away. There's less pressure on it. So that less pressure on the rock causes the rock to sort of expand just a little bit. Think of having a big stack of pillows, a lot of weight on, like a bunch of textbooks on a pillow. You take it off, the pillow will rise. A rock does similar things, but in a much smaller amount because it's rock. But that causes a lot of natural cracks in rock. So bedrock itself has a lot of natural cracks in it. This is Half Dome at Yosemite National Park in California. And you can see this sort of sheeting there. It's a pretty good example of it. These are people for scale, so this is huge. You can kind of see it here of these sort of layers that kind of come off. And that is part of the expansion due to the lack of weight on top. Please pause this and copy this down. Okay, the second type of physical weathering here is abrasion, and that's basically abrasion. What are some words that we use abrasion in the real world? Think of sandpaper on wood. That's abrasive. Okay, any sort of scratching, rubbing something harder against something, or maybe actually could be two things of high hardness. It's the rubbing and scratching. And here we're going to talk about rocks. Okay, so what I'm going to do here is I'm going to just show a brief clip of this video. I know we've seen this in class already. We're going to get it going here first. And this is showing in Alaska. This is a stream in Alaska, and it goes underwater here in a second. I know my students have seen this. And what you can see here is these small pebbles and sand rolling along. So what I want to focus on is the rolling itself along is erosion. Okay, that's the process of erosion. And look at this one here, sliding along. It kind of rolls along. As it rolls along, it is hitting into the bedrock at the bottom of the stream or the other sediments, and they're rubbing and scratching against each other. And that's abrasion. The rock's just rubbing against each other, sand hitting it, sand hitting other grains of sand. It's going to definitely wear off the edges, that process of abrasion. My example that I have here, if you see, what's going to happen is when that rock will first maybe fall off the bedrock of a big rock cliff, it's going to be angular, maybe from frost action. It will fall down into a stream. It'll be angular like this, and as it rolls along, all these sharp edges here will get worn down by, think of sand, mostly quartz, hardness of 7 rubbing up against it, and after some time it's going to be like this, and rounded like this. And that's why at the mouth of the stream, where it empties into an ocean, all the rocks are pretty much going to be rounded because they have traveled oftentimes hundreds of miles, so it has experienced a lot of abrasion.